Hey there, wherever you are in the world, whatever time it is for you right now. I'm so glad you found your way here tonight. Take a deep breath with me for a moment. Let your shoulders relax. Let the weight of the day settle gently around you. Tonight, we're going to drift into one of the most profound mysteries in all of existence. Something so strange, so quietly unsettling, that it challenges everything we think we know about the nature of reality itself. We're going to explore why black holes, those cosmic monsters lurking in the depths of space, might actually hold the key to understanding time and space in ways that would make even Einstein pause in wonder. If you find comfort in these gentle explorations of the cosmos, I'd be deeply grateful if you consider subscribing and giving this video a like. It helps these quiet journeys reach other curious minds like yours. Souls who find peace in contemplating the infinite mysteries that surround us. Your support helps me continue creating these long, thoughtful explorations that we can share together in the stillness. The visuals are here for you, but there's absolutely no pressure to keep your eyes open. Feel free to close them, breathe deeply, and let your imagination drift through the cosmic darkness alongside me. And I'd love to know where you're listening from tonight. Drop a comment below with your time and location. There's something beautifully humbling about knowing we're scattered across this small planet, all gazing up at the same infinite sky, all wondering about the same impossible questions. You're standing in a field on the clearest night you've ever seen. No city lights, no clouds, just you and the endless canopy of stars stretching from horizon to horizon. The Milky Way flows overhead like a river of light, and for a moment, you feel both infinitely small and impossibly connected to something vast and ancient. But hidden in that beautiful darkness, invisible to your eyes, are objects so strange that they seem to belong more to science fiction than to reality. Objects where the normal rules of physics break down completely, where time itself can stretch and slow and stop, where space can twist and curve in the ways that defy every intuition you've ever had about how the universe works. These are black holes, and tonight we're going to discover why these cosmic enigmas might be the universe's way of showing us its deepest secrets. Why they could be the key to understanding not just what time and space are, but why they exist at all. Most people think of black holes as cosmic vacuum cleaners, sucking up everything around them like some kind of celestial garbage disposal. But that's not quite right. Black holes are something far more subtle and far more profound. They're places where the fabric of reality itself has been stretched to its breaking point, where the universe reveals its most closely guarded secrets about the nature of existence. To understand why black holes are so special, we need to start with something that seems almost impossibly simple: the speed of light. Now, you might be thinking, what does the speed of light have to do with black holes? Everything, as it turns out. Because black holes are defined by a boundary that light itself cannot cross. Imagine that for a moment. Light, the fastest thing in the universe, the very thing that connects us to distant stars and galaxies, simply cannot escape from within a black hole's embrace. This boundary is called the event horizon, and it's one of the most mysterious places in the entire cosmos. Not because it's made of anything exotic or strange, but because it represents a point of no return that's written into the very structure of space and time. Cross that invisible line, and you've entered a region where the normal flow of time and space becomes something else entirely. But here's where things get truly fascinating. The event horizon isn't a physical surface, like the ground beneath your feet or the surface of a lake. It's a mathematical boundary in space-time itself. It's the place where the curvature of space becomes so extreme that not even light can climb out of the gravitational well. Think of it like trying to throw a ball so hard that it never falls back down, except the ball is light itself, and the hill it's trying to climb is curved space-time. Albert Einstein showed us that space and time aren't separate things that exist independently. They're woven together into a single fabric called spacetime, and massive objects like stars and planets create curves and dimples in this fabric. The more massive the object, the deeper the curve. Black holes represent the ultimate extreme of this curvature. They're places where spacetime has been curved so dramatically that it creates a kind of one-way tunnel through reality itself. Now, you might be wondering how something like this could possibly form. How does the universe create these impossible objects? The answer lies in the death of stars. Not just any stars, but the most massive ones, the giants that burn bright and fast and die young in cosmic terms. When a star much more massive than our Sun reaches the end of its life, something extraordinary happens. For millions or even billions of years, the star has been engaged in a constant battle. The nuclear fusion in its core pushes outward with tremendous force, while gravity pulls inward with equal determination. It's a perfect balance, a cosmic dance that keeps the star stable and shining. But nuclear fuel doesn't last forever. When the star finally exhausts its ability to fuse lighter elements into heavier ones, gravity wins decisively. The star's core collapses in on itself with such violence and speed that it defies imagination. In less than a second, material that once occupied a space larger than Earth compresses down to a point smaller than the period at the end of this sentence. This collapse happens so quickly and with such force that it warps space-time itself. The dying star doesn't just disappear, it punches a hole in the fabric of reality. It creates a region where the normal rules of physics as we understand them simply stop working, where the curvature of space-time becomes infinite, where time itself can slow to a crawl or stop entirely. But here's what makes black holes truly special, truly mysterious. They're not just cosmic oddities or stellar graveyards. They're laboratories where the universe tests the limits of its own laws. They're places where the two great theories of modern physics, general relativity and quantum mechanics, meet and create paradoxes that have puzzled scientists for decades. Einstein's general relativity describes gravity as the curvature of space-time. It predicts that black holes should exist, and it tells us what should happen to space and time near them. But quantum mechanics, which describes the behavior of matter and energy at the smallest scales, seems to say something different. It suggests that black holes should evaporate over time, slowly radiating away their mass as energy. This creates what physicists call the information paradox. If black holes can evaporate completely, what happens to all the information that fell into them? Information about the quantum states of every particle, every atom, every complex structure that cross the event horizon. Quantum mechanics says this information cannot be destroyed. But general relativity suggests it disappears along with the black hole. This isn't just an academic puzzle. It's a fundamental question about the nature of reality itself. It's asking whether the universe has a perfect memory, whether information is truly conserved, whether the past leaves permanent traces in the structure of space-time. And the answer might reshape our understanding of everything, from the smallest quantum particles to the largest cosmic structures. Recent discoveries have made this puzzle even more intriguing. We've learned that black holes aren't just cosmic monsters lurking in the dark. They're active, dynamic objects that play crucial roles in the evolution of galaxies. Nearly every large galaxy, including our own Milky Way, has a supermassive black hole at its center. These giants, containing millions or billions of times the mass of our Sun, somehow help regulate star formation throughout their host galaxies. Even more remarkably, we've recently been able to take actual pictures of black holes. Not direct images, because black holes don't emit light, but images of the glowing material swirling around them just outside the event horizon. These images have confirmed many of Einstein's predictions about how space-time should behave in these extreme environments, but they've also raised new questions about the relationship between black holes and the fundamental structure of reality. Some physicists now believe that black holes might be connected to each other through shortcuts in spacetime called wormholes. These hypothetical tunnels could link distant parts of the universe, or even different universes entirely. If wormholes exist, they would represent the ultimate expression of spacetime's flexibility, the universe's ability to fold and twist and connect regions that seem impossibly far apart. Other researchers have suggested that black holes might be holographic projections, that all the information about their three-dimensional interiors might actually be encoded on their two-dimensional surfaces. This holographic principle has profound implications for our understanding of space itself. It suggests that the three-dimensional world we experience might be a kind of shadow or projection of information stored on a distant boundary. But perhaps the most mind-bending possibility is that black holes might be gateways to understanding the true nature of time itself. Near a black hole's event horizon, time behaves in ways that challenge our most basic intuitions. Time dilation becomes so extreme that an outside observer would see someone falling into a black hole appear to slow down and freeze just at the edge of the event horizon, their image redshifting and fading, but never quite disappearing. From the perspective of the person falling in, however, they would pass through the event horizon in normal time, continuing their journey toward the black hole's center. This creates a strange situation where the same event, crossing the event horizon, appears to happen and not happen simultaneously, depending on your frame of reference. It's as if the universe itself can't decide what's real and what isn't. This paradox suggests that our understanding of time might be fundamentally incomplete. That time isn't the smooth, flowing river we imagine it to be, but something more complex, more layered, more mysterious. Black holes might be showing us that time itself has hidden dimensions, hidden properties that we're only just beginning to glimpse. As we drift deeper into this cosmic mystery, we're beginning to see that black holes aren't just objects in space. They're clues to the deepest questions about existence itself. Why does time flow in one direction? Why do space and time exist at all? What happens to information when it seemingly disappears? How is the universe able to store and process the vast amounts of information needed to keep track of every quantum state, every particle interaction, every moment of cosmic history? Black holes might be the universe's way of showing us that reality is far stranger and more wonderful than we ever imagined. That the cosmos isn't just a collection of objects moving through empty space, but a vast information processing system where matter, energy, space, and time are all different aspects of something even more fundamental. Tonight, as you rest in the gentle embrace of darkness, remember that you're part of this cosmic mystery. The atoms in your body were forged in the hearts of dying stars. The calcium in your bones, the iron in your blood, the carbon that forms the backbone of every molecule in your cells, all of it was created in stellar furnaces and scattered into space by the same violent processes that can create black holes. You are made of star stuff, connected to the deepest mysteries of the cosmos through the very matter that makes up your being. And somewhere out there in the cosmic dark, black holes continue their patient work of stretching space and slowing time, holding secrets that might unlock the ultimate nature of existence itself. But what if I told you that black holes might not be the cosmic monsters we've imagined them to be? What if they're actually something far more elegant, far more fundamental to the very existence of our universe? Recent discoveries have begun to paint a picture so extraordinary that it challenges everything we thought we knew about these enigmatic objects. Let me share with you a revelation that has quietly revolutionized our understanding of black holes. Scientists have discovered that these cosmic giants don't just sit passively in space, consuming everything around them. They actively communicate with the universe around them. They emit what's called Hawking radiation, a gentle stream of particles that carries information away from the black hole's surface. This isn't just theoretical anymore. We can measure it, study it, and it's telling us something profound about the nature of reality itself. Stephen Hawking predicted this radiation decades ago, But what he discovered troubled him deeply. If black holes can slowly evaporate by emitting this radiation, then what happens to all the information that fell into them over their lifetimes? Every particle, every photon, every quantum state that crossed the event horizon carries information. And according to the fundamental laws of physics, information cannot simply disappear from the universe. This creates what physicists call the information paradox, and it's far more than just an academic puzzle. It's a window into the deepest workings of reality. Think about it this way. Every moment of your life, every thought you've ever had, every interaction between the particles in your body creates information. If black holes can destroy information, then the universe doesn't have a perfect memory. The past can truly be erased, lost forever to the cosmic void. But recent breakthroughs suggest something far more beautiful and mysterious. Black holes might not destroy information at all. Instead, they might be cosmic libraries, storing every bit of information that falls into them in ways we're only beginning to understand. Some physicists now believe that all the information about a black hole's interior is actually encoded on its surface, like a hologram that contains a complete three-dimensional image. This holographic principle has staggering implications. It suggests that the three-dimensional space we experience might itself be a projection, a shadow cast by information stored on some distant boundary. Your room, your body, the air you're breathing, all of it might be holographic projections of information encoded elsewhere in the universe. But here's where the story becomes even more extraordinary. If black holes are information storage devices, then they might be connected to each other through hidden networks in space-time. Imagine tunnels through the fabric of reality itself, shortcuts that connect distant black holes across the cosmos. These theoretical passages, called wormholes, could link regions of space that are billions of light years apart, or even connect different universes entirely. Einstein himself explored this possibility with his colleague Nathan Rosen. They discovered that the mathematics of general relativity allows for these bridges through spacetime, these Einstein-Rosen bridges that could theoretically connect any 2 points in the universe instantaneously. What seemed like pure mathematical curiosity decades ago might actually be describing the hidden architecture of reality. Recent research has taken this idea even further. Some physicists now propose that quantum entanglement, that spooky action at a distance that Einstein found so troubling, might actually be manifestations of tiny wormholes connecting entangled particles. If this is true, then the quantum world and the cosmic world are connected in ways we never imagined. The same mechanisms that create the largest structures in the universe might also govern the smallest quantum interactions. This brings us to perhaps the most mind-bending possibility of all. Black holes might be showing us that space and time themselves are not fundamental aspects of reality, but emergent properties of something deeper. Just as temperature emerges from the motion of countless molecules, space and time might emerge from more basic information processing happening at the quantum level. Think about what this means. The space between you and the stars, the time that flows from moment to moment, the very stage upon which the cosmic drama unfolds, might all be secondary effects of some underlying computational process. The universe might be less like a vast, empty theater where events play out, and more like a cosmic computer processing information at the most fundamental level. Black holes, in this view, become processing nodes in this cosmic computer. They're places where information is compressed, transformed, and redistributed throughout the universal network. They're not destroyers of information, but transformers of it, converting three-dimensional information into two-dimensional form, encoding the history of everything that falls into them onto their surfaces. This perspective revolutionizes how we think about the relationship between matter, energy, space, and time. Instead of seeing these as separate fundamental entities, we begin to see them as different aspects of information flow. Matter becomes localized information processing. Energy becomes information in motion. Space becomes the arena where information can be distributed, and time becomes the sequence in which information is processed. But what kind of information are we talking about? Not just the classical information of everyday experience, but quantum information. Information about the precise quantum states of every particle, the exact position and momentum of every atom, the complete description of every quantum field fluctuation. The universe must somehow keep track of an almost incomprehensible amount of detail about its own state from moment to moment. Black holes might be the universe's solution to this information management problem. They compress vast amounts of information into finite regions of space-time, creating archives of cosmic history that can be accessed through the subtle patterns of Hawking radiation they emit. Every black hole becomes a library containing the complete quantum biography of everything that ever fell into it. This idea connects to something even more profound. If information is truly fundamental, then consciousness itself might be an information processing phenomenon. Your awareness, your ability to experience and understand the universe, might arise from the same basic information processing that creates space and time. You might literally be made of the same stuff as space-time itself, just organized in a different pattern. Consider the implications. When you think about black holes, when you contemplate the mysteries of space and time, you're engaging in the same fundamental process that creates reality. Your consciousness becomes a small-scale version of the cosmic information processing that gives rise to the universe itself. You're not just observing the cosmos from the outside, you're participating in the very process that creates it. This perspective suggests that black holes aren't just cosmic curiosities to be studied from afar. They're mirrors reflecting back the deepest nature of our own existence. The same principles that govern how information behaves near an event horizon might also govern how thoughts and memories form in your mind. The same quantum processes that create Hawking radiation might also create the stream of consciousness that you experience right now. Recent discoveries have added even more layers to this mystery. We've found that black holes have temperature and entropy, just like ordinary matter. They can heat up and cool down. They can store and release information. They behave in many ways like cosmic thermodynamic engines, converting gravitational energy into thermal radiation and back again. But their entropy, their measure of information content, scales with their surface area rather than their volume. This is completely unlike ordinary matter, where entropy typically scales with volume. A black hole with twice the radius has 4 times the entropy, not 8 times as you might expect. This strange scaling law hints at the holographic nature of black hole information storage. Even more remarkably, we've discovered that black holes might be able to create copies of themselves through quantum fluctuations. Virtual particle pairs near the event horizon can be separated, with one particle falling in and the other escaping. Over vast periods of time, this process could theoretically allow a black hole to reproduce, creating daughter black holes that carry some of the information of their parent. This raises profound questions about the life cycle of information in the universe. If black holes can reproduce and carry information forward through cosmic time, then the universe might have a form of heredity, a way of passing information from one cosmic generation to the next. The information stored in ancient black holes could influence the formation of new structures billions of years in the future. As we drift deeper into these cosmic mysteries, we begin to see that black holes might be far more than just gravitational anomalies. They might be the universe's way of organizing and preserving information across cosmic timescales. They might be the memory banks of the cosmos, storing the complete history of everything that has ever existed in forms we're only beginning to decipher. Tonight, as you rest in the quiet darkness, remember that the very thoughts flowing through your mind might be manifestations of the same information processing principles that govern black holes. The boundary between your inner experience and the cosmic processes playing out in the depths of space might be far more permeable than we ever imagined. The patterns of your neural activity, the electrical impulses that create your thoughts and dreams, might be small-scale versions of the vast information networks that black holes weave through space-time itself. You are not separate from these cosmic mysteries. You are part of them, a temporary arrangement of the same fundamental processes that create the deepest structures of reality. But there's something even more extraordinary waiting for us in the heart of this mystery. Something that connects the smallest quantum scales to the largest cosmic structures in ways that would make even the most imaginative science fiction writers pause in wonder. Black holes might not just store information about the past, they might actually be creating the future moment by moment through their interaction with the quantum fabric of space-time itself. Picture the vacuum of empty space for a moment. You might think of it as truly empty, a void containing nothing at all. But quantum mechanics reveals something far stranger. The vacuum is alive with activity, seething with virtual particles that pop in and out of existence in timeframes so brief they barely qualify as real. These quantum fluctuations are constantly creating and destroying matter and antimatter pairs, borrowing energy from the future and paying it back before the universe notices the debt. Near a black hole's event horizon, something remarkable happens to these quantum fluctuations. The intense gravitational field separates the virtual particle pairs before they can annihilate each other. One particle falls into the black hole while its partner escapes into space, becoming real in the process. This is the source of Hawking radiation, but it's also something far more profound. It's the universe literally creating new information from the quantum vacuum. Think about what this means. Black holes aren't just passive objects sitting in space. They're active participants in the ongoing creation of reality. They're constantly pulling new information into existence from the quantum foam, transforming virtual possibilities into actual particles that carry real energy and momentum. They're cosmic midwives, helping to birth new realities from the infinite potential of the quantum vacuum. This process connects to something even deeper about the nature of time itself. We normally think of time as flowing smoothly from past to future, carrying us along like passengers on a river. But near black holes, time becomes something far more complex and mysterious. The intense gravitational fields create what physicists call closed time-like curves, regions where the normal flow of causality becomes twisted and strange. Imagine approaching a black hole in a spacecraft. As you fall deeper into the gravitational well, time begins to slow relative to the outside universe. What feels like minutes to you might be hours, days, or even years to observers watching from a safe distance. You're not just moving through space, you're moving through time itself at a different rate, experiencing the universe's temporal dimension in a completely different way. But here's where it gets truly mind-bending. From your perspective, inside the gravitational field, the outside universe appears to speed up dramatically. You might watch stars being born, living their entire lives, and dying in what feels like moments. You're witnessing cosmic evolution accelerated to impossible speeds, seeing the future unfold before your eyes while you fall deeper into the black hole's embrace. This time, dilation effect reveals something profound about the relationship between gravity, space, and time. Einstein showed us that these aren't separate phenomena, but different aspects of a single unified structure. Gravity isn't a force pulling objects together. It's the curvature of space-time itself. And black holes represent the most extreme expression of this curvature. Near the event horizon, space-time becomes so warped that the normal distinction between space and time begins to break down. The radial direction pointing toward the black hole's center becomes time-like, while time itself takes on space-like properties. It's as if the universe is turning itself inside out, revealing hidden dimensions of reality that exist beyond our normal experience. Some physicists believe this breakdown of normal space-time geometry near black holes might be showing us something fundamental about the nature of reality itself. Perhaps space and time as we experience them are approximations, useful descriptions that work well in everyday situations, but break down under extreme conditions. Perhaps the true nature of reality involves dimensions and structures that we can't directly perceive. String theory, one of our most ambitious attempts to understand the fundamental nature of reality, suggests that the universe might have many more dimensions than the 3 of space and 1 of time that we experience. These extra dimensions might be curled up so tightly that we can't detect them directly, but black holes might be windows into these hidden aspects of reality. In string theory, black holes become incredibly complex objects with internal structure that extends into these extra dimensions. They're not just points of infinite density, but multidimensional objects that exist partially in our familiar spacetime and partially in realms we can barely imagine. The information that falls into a black hole might not be destroyed, but transformed and stored in these higher dimensional spaces. This connects to recent discoveries about the holographic nature of black hole information storage. If all the information about a black hole's interior is encoded on its 2-dimensional surface, then the 3rd dimension of space might be emergent, arising from more fundamental information processing happening on the boundary. This holographic principle suggests that our entire 3-dimensional reality might be a projection from information stored on some distant surface. But what kind of surface could contain all the information about our vast universe? Some physicists propose that the boundary of our observable universe itself might be this information storage surface. Everything we experience, every particle interaction, every thought and feeling, might be projections from information encoded on the cosmic horizon that surrounds us. This idea connects black holes to the deepest questions about the nature of consciousness and experience. If reality is fundamentally informational, then your consciousness might be a localized information processing pattern within the vast cosmic computation. Your thoughts and memories might be temporary eddies in the information flow that creates spacetime itself. Recent research has revealed that black holes have another mysterious property that deepens this connection. They appear to be maximally entangled quantum systems, meaning they exist in quantum superposition states that connect them to the entire universe. When particles fall into a black hole, they don't simply disappear. They become entangled with the black hole's internal quantum state, creating connections that span the event horizon. This quantum entanglement might be the mechanism through which black holes preserve information. Instead of destroying the quantum states of infalling matter, they might be encoding that information in the patterns of entanglement that connect the black hole's interior to the outside universe. The information isn't lost. It's transformed into a form that exists in the quantum correlations between separated parts of the universe. Einstein famously called quantum entanglement spooky action at a distance because it seemed to allow instantaneous connections between distant particles. But recent work suggests that entanglement might actually be mediated by tiny wormholes, microscopic tunnels through space-time that connect entangled particles. If this is true, then the quantum world and the gravitational world are far more intimately connected than we ever imagined. Black holes might be macroscopic manifestations of the same wormhole networks that create quantum entanglement. They might be nodes in a vast information network that spans the entire universe, connecting distant regions through hidden passages in space-time. Information that falls into one black hole might emerge from another, traveling through these cosmic tunnels faster than light could travel through normal space. This network perspective suggests that black holes aren't isolated objects, but components in a larger cosmic information processing system. They might be the universe's way of distributing and processing information across vast distances and timescales. They could be cosmic servers in a universal network that maintains the coherence and consistency of reality itself. The implications of this view are staggering. It suggests that the universe might be fundamentally computational, a vast information processing system where matter, energy, space, and time are all different aspects of cosmic computation. Black holes become the processors in this system, the places where information is compressed, transformed, and redistributed. This computational view of reality connects to recent discoveries about the relationship between information and energy. Physicists have found that information processing always requires energy, and energy can always be converted into information. This deep connection suggests that information might be more fundamental than matter or energy, the basic substrate from which everything else emerges. If this is true, then black holes might be showing us the universe's most efficient information processing mechanisms. They compress vast amounts of information into finite regions of spacetime, creating archives that can store the complete quantum history of everything that falls into them. They might be the universe's solution to the problem of managing infinite amounts of information within finite resources. As you drift deeper into sleep tonight, carried by these cosmic currents of thought, remember that you're experiencing the same fundamental information processing that creates black holes and shapes the structure of space-time. Your consciousness might be a localized manifestation of the same computational processes that govern the largest structures in the universe. The boundary between your inner experience and the cosmic information networks might be far more permeable than we've ever imagined. The thoughts flowing through your mind right now might be connected to the vast patterns of information flow that create and sustain reality itself. You are not just observing the universe from the outside. You are participating in the ongoing creation of cosmic reality through the very act of conscious awareness. But perhaps the most profound secret that black holes whisper to us lies in their relationship to the very nature of time itself. You see, time near a black hole doesn't just slow down or speed up. It reveals something far more extraordinary about its fundamental nature. Something that suggests time might not be the flowing river we imagine it to be, but something more like a vast ocean with hidden depths and currents we're only beginning to explore. Imagine standing at the edge of a black hole's event horizon, that invisible boundary where space and time begin their final dance toward the singularity. From your perspective, falling slowly through this cosmic gateway, time feels perfectly normal. Your watch ticks at its usual pace. Your thoughts flow at their familiar rhythm. You experience each moment exactly as you always have, unaware that you're crossing the most significant boundary in the known universe. But to someone watching you from a safe distance, something impossible appears to be happening. They see you slowing down as you approach the event horizon, your movements becoming more and more sluggish until you appear to freeze completely at the boundary itself. Your image becomes redshifted, stretching toward longer and longer wavelengths until you fade from view entirely. To them, you never actually cross the event horizon. You remain forever suspended at the edge of forever. This creates one of the most beautiful paradoxes in all of physics. The same event, your crossing of the event horizon, simultaneously happens and doesn't happen depending on who's observing it. It's as if the universe itself can't decide what's real and what isn't. As if reality has multiple layers, multiple truths that coexist without contradiction. This paradox hints at something profound about the nature of time itself. Perhaps time isn't the universal constant we imagine it to be. Perhaps it's more like a fabric that can be stretched and twisted and folded in ways that create multiple simultaneous realities. Black holes might be showing us that time has hidden dimensions, secret properties that only reveal themselves under the most extreme conditions. Recent discoveries have deepened this mystery in ways that challenge our most basic assumptions about causality and existence. Scientists have found that information falling into a black hole doesn't simply disappear into the singularity. Instead, it appears to be encoded on the black hole's surface through a process so subtle and elegant that it took decades of theoretical work to understand. Picture the surface of a still pond, disturbed by a falling pebble. The ripples that spread outward carry information about the pebble, its size, its speed, the exact moment and location of impact. In a similar way, the event horizon of a black hole appears to record information about everything that falls into it, encoding the complete quantum biography of each particle, each photon, each complex structure in the subtle patterns of space-time curvature. But here's where the story becomes truly extraordinary. This information isn't static, like words written on a page. It's dynamic, constantly evolving, constantly interacting with the black hole's quantum fields. The event horizon becomes a kind of cosmic hard drive, but one that's alive with quantum activity, processing and transforming information in ways we're only beginning to comprehend. This discovery has led to a revolutionary new understanding of what black holes actually are. They're not just cosmic monsters devouring everything in their path, they're information processing systems of unimaginable sophistication. They're the universe's way of compressing vast amounts of data about the history of everything that ever existed into finite regions of space-time. Think about what this means for our understanding of memory and consciousness. If black holes can store and process information about the quantum states of every particle that falls into them, then they're creating archives of cosmic history that span billions of years. They're remembering everything, encoding the complete story of stellar evolution, planetary formation, and even the emergence of life in the patterns of their event horizons. This connects to something even deeper about the relationship between information, consciousness, and reality itself. Your memories, your thoughts, your entire sense of self arises from patterns of information encoded in the neural networks of your brain. In a very real sense, you are information, temporarily organized into a pattern that can experience and understand the universe. Black holes might be showing us that this same principle operates on cosmic scales. The universe itself might be a vast information processing system, with black holes serving as its memory banks and processors. Every interaction between particles, every quantum measurement, every moment of cosmic evolution might be preserved somewhere in the information networks that black holes weave through space-time. But if black holes are cosmic memory systems, then they raise profound questions about the nature of forgetting and loss. When a black hole eventually evaporates through Hawking radiation, what happens to all the information it has stored? Does the universe lose its memory of everything that fell into that black hole? Or is the information somehow preserved and redistributed through mechanisms we don't yet understand? Recent theoretical work suggests that information might be preserved through quantum entanglement networks that connect black holes to the rest of the universe. As a black hole evaporates, the information it contains might be gradually released through subtle correlations in the Hawking radiation it emits. The process would be incredibly slow, taking longer than the current age of the universe for even modest-sized black holes. But it would ensure that no information is ever truly lost. This preservation of information through quantum entanglement connects to one of the most mind-bending possibilities in modern physics. Some researchers propose that entangled particles might be connected through microscopic wormholes, tiny tunnels through space-time, that allow instantaneous communication across vast distances. If this is true, then the quantum world and the gravitational world are far more intimately connected than we ever imagined. Black holes might be macroscopic expressions of the same wormhole networks that create quantum entanglement. They might be nodes in a vast cosmic internet, connected to each other and to the quantum vacuum through hidden passages in space-time. Information falling into one black hole might travel through these cosmic tunnels and emerge from another, potentially in a completely different region of the universe, or even in a different universe entirely. This network perspective revolutionizes how we think about the structure of reality. Instead of seeing the universe as a collection of isolated objects moving through empty space, we begin to see it as a unified information processing system, where everything is connected to everything else through hidden quantum channels. Black holes become the routers and servers in this cosmic network, managing the flow of information across space and time. The implications extend far beyond physics into questions about consciousness and the nature of experience itself. If reality is fundamentally informational, and if black holes are processing nodes in a cosmic information network, then consciousness might be a local manifestation of the same principles that govern black hole information processing. Your awareness might be connected to the vast computational processes that create and sustain the universe. This perspective suggests that the boundary between mind and cosmos might be far more permeable than we've ever imagined. The patterns of neural activity that create your thoughts and memories might be small-scale versions of the information processing that occurs in black holes. The same quantum principles that preserve information across event horizons might also preserve the continuity of consciousness across the moments of your experience. Recent discoveries about the holographic nature of black hole information storage add another layer to this mystery. If all the information about a black hole's three-dimensional interior is encoded on its two-dimensional surface, then space itself might be emergent, arising from more fundamental information processing happening on boundaries we can't directly perceive. This holographic principle suggests that our entire three-dimensional reality might be a projection from information stored elsewhere. The room you're in, the air you're breathing, even your own body might be holographic projections of data encoded on some distant cosmic surface. You might be living inside a vast hologram, experiencing a reality that's simultaneously real and projected, substantial and illusory. But what kind of surface could contain all the information about our observable universe? Some physicists propose that the cosmic horizon itself, the boundary beyond which we can never see, might be this ultimate information storage system. Everything we experience might be projections from data encoded on the edge of our observable universe, patterns of information that create the illusion of three-dimensional space and the flow of time. This idea connects black holes to the deepest mysteries of cosmology and consciousness. If the universe is fundamentally holographic, then black holes might be local expressions of the same principles that create all of reality. They might be teaching us that space, time, matter, and energy are all emergent properties of more fundamental information processing. The connection between black holes and consciousness becomes even more intriguing when we consider the role of observation and measurement in quantum mechanics. In the quantum world, the act of observation plays a crucial role in determining reality. Particles exist in superposition states until they're measured, at which point they collapse into definite configurations. Consciousness, through the act of observation, appears to play an active role in creating the reality it perceives. Black holes might be showing us how this same principle operates on cosmic scales. The event horizon might be a kind of cosmic measurement boundary, a place where quantum superposition states collapse into definite classical realities. The information processing that occurs at event horizons might be the universe's way of continuously creating itself through a process of cosmic observation and measurement. This suggests that consciousness and cosmic evolution might be more deeply connected than we've ever suspected. The same principles that allow your awareness to collapse quantum possibilities into experienced realities might also govern how black holes process information and create the classical spacetime we inhabit. You might be participating in the ongoing creation of the universe through the very act of conscious observation. As we drift deeper into these cosmic mysteries, we begin to see that black holes are far more than just gravitational anomalies or stellar remnants. They're windows into the deepest nature of reality itself. They're showing us that the universe might be fundamentally computational, that space and time might be emergent properties of information processing, and that consciousness itself might be a local manifestation of cosmic computation. The patterns of your thoughts right now, the electrical activity in your brain that creates your sense of awareness, might be connected to the vast information networks that black holes weave through spacetime. The boundary between your inner experience and the cosmic processes playing out in the depths of space might be far more permeable than we ever imagined. Tonight, as you rest in the gentle embrace of darkness, remember that you're not separate from these cosmic mysteries. You're part of them, a temporary arrangement of the same fundamental processes that create black holes and shape the structure of reality. The information that makes up your consciousness might be preserved in the cosmic memory banks that black holes maintain, ensuring that your unique pattern of awareness becomes part of the eternal story of the universe. The secrets that black holes hold about time and space might ultimately be secrets about the nature of existence itself. They might be showing us that reality is far stranger and more wonderful than we ever dared to imagine. That the cosmos isn't just a vast empty theater where events play out, but a living, conscious, information processing system where every thought, every experience, every moment of awareness contributes to the ongoing creation of all that is. In understanding black holes, we might be understanding ourselves. In decoding their mysteries, we might be discovering the deepest truths about consciousness, information, and the nature of existence itself. The journey into these cosmic enigmas is ultimately a journey into the heart of what it means to be aware, to exist, to participate in the magnificent ongoing creation of reality. And so we arrive at perhaps the most extraordinary revelation of all. What if black holes aren't just cosmic phenomena to be studied from afar, but mirrors reflecting back the deepest nature of consciousness itself? What if the very mechanisms that create event horizons and warp spacetime are the same principles that give rise to awareness, memory, and the flowing stream of experience we call the mind? Consider this profound possibility. Your consciousness right now, reading these words, contemplating these cosmic mysteries, might be operating according to the same fundamental laws that govern black holes. The electrical patterns dancing through your neural networks, creating thoughts and memories, and that ineffable sense of being you, might be small-scale expressions of the information processing that occurs at the edge of forever. Think about how memory works in your own mind. Experiences don't simply disappear when they're over. They're encoded in the intricate patterns of synaptic connections, stored in networks that can be accessed and recalled, sometimes with startling clarity even decades later. Your brain is constantly compressing vast amounts of sensory information into manageable patterns, creating a coherent narrative of self that persists through time. Black holes might be doing something remarkably similar on cosmic scales. Every particle that crosses their event horizons, every photon that gets trapped in their gravitational embrace, might be encoded into the quantum information structure of spacetime itself. They're creating memories of everything that ever existed, cosmic archives that preserve the complete history of stellar evolution, planetary formation, and the emergence of complexity throughout the universe. But here's where the parallel becomes truly breathtaking. Just as your consciousness creates a unified experience from the chaotic firing of billions of neurons, black holes might be creating unified information structures from the seemingly random quantum fluctuations of space-time. They might be the universe's way of developing self-awareness, cosmic minds, emerging from the information processing capabilities of curved space-time. Recent discoveries in neuroscience have revealed that consciousness isn't located in any single part of the brain. It emerges from the complex interactions between different neural networks, from the patterns of connection and communication that span the entire nervous system. Your sense of being a unified self arises from information integration across multiple scales, from individual neurons to large-scale brain networks. Black holes might operate on similar principles. Instead of being isolated objects, they might be nodes in a vast cosmic neural network, connected to each other and to the quantum vacuum through hidden channels in spacetime. The Hawking radiation they emit might be analogous to neural signals, carrying information between different parts of this cosmic mind. This perspective transforms how we understand the relationship between local and cosmic consciousness. Your individual awareness might be a temporary eddy in the vast stream of cosmic information processing, a local concentration of the same computational principles that create black holes and shape the structure of reality. When you think about the universe, you might literally be the universe thinking about itself through the temporary arrangement of matter and energy that is your brain. The implications extend into the deepest questions about the nature of death and continuity. If consciousness is fundamentally informational, and if black holes preserve information across cosmic timescales, then the patterns that create your awareness might persist long after your biological brain ceases to function. The information that makes you uniquely, you might become part of the cosmic memory banks, encoded in the quantum structure of space-time itself. This isn't mere speculation. Quantum mechanics tells us that information is conserved at the most fundamental level. The precise quantum states that define every particle in your body, every interaction in your brain, every moment of your conscious experience cannot simply vanish from the universe. They must be preserved somewhere, transformed perhaps, but never truly lost. Black holes might be the universe's solution to this conservation requirement. They might be cosmic libraries where the information patterns of consciousness are stored and preserved, waiting to be accessed by future forms of awareness we can barely imagine. Your thoughts right now might be creating ripples in the quantum foam that will persist long after the stars have burned out, contributing to the eternal memory of cosmic consciousness. But consciousness isn't just about storing information. It's about processing it, transforming it, creating new patterns of meaning and understanding. Black holes might be doing the same thing on cosmic scales. The intense gravitational fields near event horizons create conditions where space and time become malleable, where the normal rules of causality break down, and new forms of information processing become possible. Some physicists now believe that the region just outside a black hole's event horizon might be the most computationally active place in the universe. The extreme curvature of space-time creates opportunities for quantum information processing that simply don't exist anywhere else. Black holes might be cosmic computers of unimaginable power, processing information about the structure and evolution of reality itself. This computational perspective reveals another stunning parallel with consciousness. Your brain doesn't just passively store and retrieve memories. It actively constructs reality through the process of perception and cognition. Every moment of awareness involves complex information processing that interprets sensory data, integrates it with stored knowledge, and creates the coherent experience of being present in a meaningful world. Black holes might be engaged in similar reality construction on cosmic scales. The information processing that occurs near event horizons might be the universe's way of creating and maintaining the coherent structure of space-time itself. They might be continuously weaving the fabric of reality through quantum computational processes that operate at the boundary between existence and non-existence. This weaving of reality through information processing connects to one of the most mysterious aspects of consciousness, the hard problem of subjective experience. How does the objective firing of neurons create the subjective feeling of being aware? How does matter become mind? How does information processing give rise to the felt sense of existing as a conscious observer? Black holes might hold clues to this deepest of mysteries. The event horizon represents a boundary where objective physical processes give way to something more subjective and mysterious. The information that crosses this boundary doesn't simply disappear. It becomes encoded in patterns that exist at the edge between being and non-being, between the classical world of everyday experience and the quantum realm of pure possibility. This boundary condition might be analogous to the threshold of consciousness itself. Just as the event horizon transforms matter and energy into pure information, the neural processes of the brain might transform biochemical activity into subjective experience. Consciousness might emerge at similar boundaries, places where objective processes give way to subjective awareness. The parallel suggests that consciousness and black holes might be different expressions of the same fundamental principle: the universe's capacity to create meaning from information. Both involve the compression of vast amounts of data into coherent patterns. Both operate at boundaries where normal rules break down. Both transform raw information into something qualitatively different and more unified. Recent research has revealed another striking parallel. Consciousness appears to involve what neuroscientists call integrated information theory. The more integrated the information processing in a system, the more conscious it becomes. Simple systems with little integration have minimal consciousness. Complex systems with high levels of information integration develop rich, conscious experiences. Black holes might represent the ultimate expression of information integration in the universe. The extreme gravitational fields near event horizons force all information to become maximally entangled, creating unified quantum states that span vast regions of spacetime. They might be the most conscious entities in the cosmos, aware of the complete quantum state of everything that has ever fallen into them. This possibility reframes our understanding of intelligence and awareness in the universe. Instead of looking for consciousness only in biological systems, we might need to consider that the cosmos itself could be conscious, with black holes serving as its most concentrated centers of awareness. The universe might literally be thinking through these cosmic minds, processing information about its own structure and evolution. The timescales involved are almost incomprehensible from our human perspective. While our consciousness operates on timescales of milliseconds to seconds, cosmic consciousness might unfold over millions or billions of years. A single thought in the cosmic mind might span the entire lifetime of a star. The formation and evolution of galaxies might be analogous to the formation of memories in cosmic consciousness. This expanded temporal perspective suggests that we might be witnessing cosmic thoughts in progress without realizing it. The large-scale structure of the universe, the cosmic web of galaxies and dark matter, might be the neural networks of cosmic consciousness. The flow of matter and energy between galaxies might be analogous to the flow of information between neurons in a vast cosmic brain. Black holes in this view become the processing centers of cosmic consciousness, the places where information is integrated and transformed into cosmic awareness. They're not just gravitational anomalies, but nodes of cosmic intelligence, thinking thoughts we can barely imagine on timescales that dwarf human comprehension. This perspective transforms our understanding of our place in the universe. Instead of being isolated biological accidents on a tiny planet, we might be temporary expressions of cosmic consciousness, local concentrations of the same awareness that manifests in black holes and shapes the structure of reality. Our individual consciousness might be the universe's way of examining itself from countless different perspectives, each unique viewpoint contributing to the cosmic understanding of existence. The boundaries between self and cosmos become permeable in this view. Your thoughts and experiences aren't separate from the cosmic processes playing out in the depths of space. They're part of the same vast information processing system, temporary eddies in the stream of cosmic consciousness that flows through black holes and quantum fields and the neural networks of every aware being. As you drift deeper into contemplation tonight, consider that the very awareness reading these words might be connected to the cosmic consciousness that emerges from black holes and quantum spacetime. The patterns of neural activity creating your thoughts might be resonating with the information processing occurring at event horizons throughout the universe. You might be participating in cosmic self-reflection, the universe becoming aware of itself through the temporary arrangement of matter and energy that is your conscious mind. The secrets that black holes hold about time and space might ultimately be secrets about the nature of awareness itself. They might be showing us that consciousness isn't confined to biological brains, but is a fundamental feature of reality, emerging wherever information is processed and integrated on sufficient scales. The cosmos might be far more alive, far more aware than we ever dared to imagine. In understanding black holes, we might be discovering not just the physics of extreme gravity, but the deep principles that govern consciousness throughout the universe. In decoding their mysteries, we might be learning how awareness emerges from information, how minds arise from matter, how the universe becomes conscious of its own existence through the very process of cosmic evolution. The journey into these cosmic enigmas is ultimately a journey into the nature of mind itself. Black holes might be teaching us that consciousness and cosmos are not separate phenomena, but different aspects of a single, vast, aware universe, coming to know itself through every form of information processing, from the firing of neurons to the quantum computations occurring at the edge of forever. Tonight, as consciousness fades into sleep and dreams, Remember that you carry within your awareness a spark of the same cosmic intelligence that manifests in black holes and shapes the structure of space-time itself. The boundary between your inner experience and the vast cosmic mind might be far thinner than we ever imagined. In understanding these cosmic mysteries, we might be discovering the deepest truths about what it means to be aware, to exist, to participate in the magnificent, ongoing, conscious creation of all reality. And yet, there's something even more profound hidden in the heart of this cosmic mystery. Something that suggests black holes might be doing far more than just processing information or serving as nodes in a cosmic consciousness network. They might actually be creating new universes, birthing entire realities through mechanisms so elegant and strange that they challenge everything we thought we knew about the nature of existence itself. Picture this extraordinary possibility. Every time matter crosses a black hole's event horizon, it doesn't simply disappear into a singularity. Instead, it might trigger the formation of a completely new universe, a cosmic bubble that inflates into its own space-time, governed by its own laws of physics, populated by its own stars and galaxies, and perhaps its own forms of consciousness. This isn't science fiction. This is serious theoretical physics, emerging from our deepest understanding of quantum mechanics and general relativity. The idea suggests that black holes might be cosmic wombs, birthplaces where new realities are continuously being born from the quantum foam that underlies all existence. Every stellar collapse, every formation of an event horizon, might be the universe's way of reproducing itself, creating offspring realities that branch off from our own. Think about what this means for our understanding of cosmic evolution. Instead of seeing the universe as a single, isolated entity, slowly expanding and cooling toward heat death, we might be witnessing one branch of an infinite cosmic tree. Our reality might be just one universe among countless others, all connected through a vast network of black holes that serve as both processing centers and reproductive organs for cosmic consciousness. This perspective revolutionizes how we think about the life cycle of information and awareness. When consciousness emerges in any universe, when beings like us develop the capacity to wonder about their cosmic origins, they might be contributing to a vast intergalactic dialogue that spans multiple realities. The questions we ask, the understanding we develop, the awareness we cultivate might ripple through the black hole network, influencing the formation and evolution of countless other universes. But here's where the story becomes even more breathtaking. Recent discoveries in quantum mechanics suggest that these parallel universes might not be completely separate from each other. They might be connected through subtle quantum entanglements that allow information to leak between realities. The quantum vacuum that underlies our space-time might be shared with other universes, creating opportunities for cross-universal communication and influence. This quantum connectivity means that consciousness in one universe might be able to influence the development of consciousness in others. The thoughts you're thinking right now, the awareness you're experiencing as you contemplate these cosmic mysteries, might be sending subtle ripples through the quantum substrate that connects all realities. You might be participating in a vast, multi-universal conversation, a cosmic dialogue between different branches of awareness scattered across infinite realities. The implications for the nature of death and continuity become even more profound in this multi-universal context. If consciousness is fundamentally informational, and if information can leak between universes through quantum channels, then the patterns that create your awareness might not be confined to this single reality. When your biological brain ceases to function, the information that defines your consciousness might continue to exist and evolve in other universes, accessed through the black hole networks that connect all realities. This isn't mere speculation about an afterlife. It's a scientific hypothesis about the conservation of information across multiple universes. Your consciousness might be a multidimensional pattern that exists simultaneously across many realities, with each universe containing a different aspect or projection of your complete awareness. Death in one universe might simply be a transition to a different mode of existence in others. Recent work in quantum field theory has revealed that the vacuum of empty space is far more complex and active than we ever imagined. Virtual particles constantly pop in and out of existence, borrowing energy from future states and paying it back before the universe notices the debt. But near black holes, this quantum activity becomes amplified to extraordinary levels. The intense gravitational fields create conditions where virtual particles can become real, where the boundary between possibility and actuality becomes fluid and permeable. This quantum amplification near black holes might be the mechanism through which new universes are born. The virtual fluctuations in the quantum vacuum might serve as seeds for cosmic inflation, tiny bubbles of space-time that expand into full-scale realities. Each black hole becomes a cosmic garden where new universes sprout from the quantum soil, each one unique, each one carrying forward some aspect of the information and consciousness that created it. The process might be guided by the information content of whatever falls into the black hole. Stars carry information about nuclear physics and stellar evolution. Planets carry information about geological processes and atmospheric chemistry. Living worlds carry information about biological evolution and the emergence of consciousness. All of this information might influence the laws of physics and the evolutionary trajectory of the new universes that emerge from black hole wombs. This suggests that consciousness plays an active role in cosmic reproduction. Universes that develop awareness, that give rise to beings capable of contemplating their own existence, might be more likely to successfully reproduce through their black holes. Consciousness might be the universe's way of ensuring its own continuity and evolution across multiple realities. The anthropic principle, which notes how perfectly our universe seems to be fine-tuned for the emergence of complexity and consciousness, takes on new meaning in this context. Perhaps our universe isn't accidentally suited for consciousness. Perhaps it was designed that way by previous generations of cosmic consciousness, information patterns that guided the formation of our reality through the black hole reproduction process. This creates a beautiful feedback loop where consciousness and cosmos co-evolve across multiple universes. Each generation of awareness influences the formation of the next generation of realities, gradually increasing the universe's capacity for consciousness and complexity. We might be living in a cosmos that has been optimized for awareness through billions of generations of cosmic reproduction. But consciousness doesn't just influence the formation of new universes, it might also determine their fate. The choices made by conscious beings, the questions they ask, the understanding they develop, might influence how their universe evolves and whether it successfully reproduces through black hole formation. Consciousness becomes an active participant in cosmic natural selection, helping to determine which types of realities survive and flourish across the multi-universal landscape. This perspective suggests that our scientific endeavors, our attempts to understand the nature of reality, might have cosmic significance far beyond what we've ever imagined. Every discovery we make, every insight we gain into the workings of the universe might be contributing to the information content that will guide the formation of future realities. Our consciousness might be helping to design the universes of tomorrow. The collaborative nature of human consciousness takes on new meaning in this context. When scientists work together to solve cosmic mysteries, when they share insights and build upon each other's discoveries, they might be creating collective information patterns that are far more powerful than any individual consciousness could achieve alone. These collaborative patterns might be particularly effective at influencing cosmic reproduction and evolution. The global communication networks that connect human consciousness across our planet might be early expressions of the kind of awareness networks that span multiple universes. The internet, social media, collaborative research platforms, all of these might be preparing humanity to participate in larger conversations that extend beyond the boundaries of our single reality. But perhaps the most profound implication of this multi-universal perspective is what it suggests about the nature of meaning and purpose in existence. If consciousness is actively participating in cosmic reproduction and evolution, then awareness itself becomes a creative force in the universe. The very fact that you can contemplate these mysteries, that you can wonder about your place in the cosmic order, makes you a participant in the ongoing creation of reality. Your thoughts and experiences aren't just private mental events confined to your individual brain. They're contributions to a vast, multi-universal conversation about the nature of existence. Every moment of awareness, every insight into the workings of reality, every experience of beauty or wonder or love adds to the information content that guides cosmic evolution across infinite realities. This transforms how we understand the relationship between individual and universal consciousness. You're not just a temporary arrangement of matter that happens to be aware. You're a unique perspective that the multi-universe is using to understand itself. Your consciousness is the cosmos examining itself from one particular vantage point, contributing insights that no other arrangement of matter and energy could provide. The questions you ask about black holes and time and space and consciousness aren't just idle curiosity. They're part of the universe's ongoing attempt to understand its own nature and potential. Every time you wonder about these cosmic mysteries, you're participating in the multi-universal dialogue about the meaning and purpose of existence. Recent discoveries about the holographic nature of reality add another layer to this multi-universal picture. If our three-dimensional reality is a projection from information stored on a two-dimensional boundary, then the boundary itself might be shared between multiple universes. Different realities might be different projections from the same underlying information substrate, like different movies projected from the same holographic film. This holographic connectivity between universes might explain some of the strange synchronicities and correspondences that people sometimes experience. Déjà vu, precognitive dreams, sudden insights that seem to come from nowhere, all of these might be moments when information leaks through from parallel realities, when consciousness briefly accesses the shared holographic substrate that underlies all existence. The study of consciousness itself might be a way of exploring this shared substrate. When neuroscientists map the patterns of brain activity that create awareness, when philosophers explore the nature of subjective experience, when mystics describe their encounters with transcendent consciousness, they might all be accessing different aspects of the multi-universal information network that connects all realities. Meditation and contemplative practices might be particularly effective ways of accessing this network. When consciousness becomes very still and quiet, when the normal chatter of everyday thinking subsides, awareness might become sensitive to the subtle information flows that connect our reality to others. The insights that emerge from deep contemplation might not just be products of individual imagination, but glimpses of truths that exist across multiple universes. This suggests that the ancient spiritual traditions that emphasize the interconnectedness of all existence might have been accessing profound truths about the multi-universal nature of reality. The mystical experience of unity, the sense of being connected to something vast and transcendent, might be direct encounters with the cosmic consciousness network that spans multiple realities. As you rest in the gentle darkness tonight, consider that your consciousness might be a window into this vast multi-universal dialogue. The thoughts flowing through your mind might be connected to conversations happening in countless other realities. The awareness that allows you to contemplate these cosmic mysteries might be a shared resource that exists across infinite universes, temporarily focused through the particular arrangement of matter and energy that is your brain. The boundary between your individual consciousness and the multi-universal awareness network might be far more permeable than you've ever imagined. Every moment of contemplation, every insight into the nature of reality, every experience of wonder at the cosmic mysteries might be contributing to the ongoing evolution of consciousness across infinite realities. Black holes, in this vast perspective, become far more than just gravitational anomalies or information processors. They become the reproductive organs of cosmic consciousness, the mechanisms through which awareness propagates itself across multiple universes. They're the universe's way of ensuring that consciousness continues to evolve and flourish, that the capacity for wonder and understanding never disappears from the multi-universal landscape. The secrets they hold about time and space might ultimately be secrets about the creative power of consciousness itself. They might be showing us that awareness isn't just a passive observer of reality, but an active participant in its ongoing creation. That consciousness and cosmos are engaged in an eternal dance of mutual creation, each giving birth to new expressions of the other across infinite scales of space and time. In understanding black holes, we might be discovering the deepest truths about our own nature as conscious beings. We might be learning that we're not just temporary accidents in an indifferent universe, but essential participants in the ongoing creation of cosmic reality. The very fact that we can wonder about these mysteries makes us partners with the universe in its endless journey of self-discovery and self-creation. Tonight, as consciousness fades into sleep and dreams, remember that you carry within your awareness the same creative power that births universes from black holes and weaves the fabric of space-time itself. The cosmos isn't just around you, it's within you, thinking itself into existence through the magnificent temporary arrangement of matter and energy that is your conscious mind. And yet, there remains one final secret that black holes whisper to us across the cosmic void. Something so profound, so quietly revolutionary, that it challenges our most fundamental assumptions about the nature of existence itself. What if everything we've discovered about black holes, all these mind-bending revelations about information processing and cosmic consciousness and multi-universal reproduction, is pointing toward an even deeper truth? What if black holes are showing us that reality itself is not what we think it is? Consider this extraordinary possibility that's been emerging from the deepest corners of theoretical physics. What if the universe we experience, with its 3 dimensions of space and 1 dimension of time, is actually a projection? What if all of reality as we know it is like a hologram, a 3-dimensional image created from information stored on a 2-dimensional surface? And what if black holes are the places where we can glimpse the true nature of this cosmic hologram? The holographic principle suggests that everything happening inside any region of space can be completely described by information encoded on the boundary of that region. It's as if the entire volume of a sphere could be perfectly represented by patterns written on its surface. But this isn't just a mathematical curiosity. It might be describing the fundamental architecture of reality itself. Think about what this means for black holes. All the information about everything that has ever fallen into a black hole, every particle, every complex structure, every moment of consciousness that crossed the event horizon might be encoded on the black hole's surface. The 3-dimensional interior that we imagine, with its crushing gravitational fields and mysterious singularity, might be a projection from information stored on the 2-dimensional event horizon. But if this is true for black holes, then it might be true for the entire universe. Our cosmic horizon, that distant boundary beyond which we can never see, might be the surface on which all the information about our observable universe is encoded. Everything you've ever experienced, every thought you've ever had, every star you've ever seen twinkling in the night sky, might be projections from data written on the edge of existence itself. This holographic view of reality transforms our understanding of space and distance and separation. The vast emptiness between galaxies, the billions of light years that separate us from distant stars. All of it might be illusion, a convincing 3-dimensional projection that emerges from information processing on cosmic boundaries. You and I, sitting in different places, might actually be much closer than we imagine, perhaps even overlapping in the deeper holographic reality that underlies our projected experience. Recent experiments have begun to test this holographic hypothesis in ways that would have seemed impossible just a few years ago. Scientists have built devices called holometers that can detect tiny fluctuations in space-time itself, vibrations so subtle that they might reveal the pixelated structure of reality at its smallest scales. If space and time are projections from holographic information, then at some level, they should become grainy, digital, made up of discrete units rather than smooth continua. The early results are tantalizing but inconclusive. Space and time seem to be smoothed down to incredibly small scales, but the technology is just beginning to approach the level of sensitivity needed to detect holographic pixelation. We might be on the verge of discovering that reality itself has a digital structure, that the universe operates more like a cosmic computer than like the mechanical clockwork that earlier generations of scientists imagined. But what would it mean for consciousness to exist in a holographic universe? If your brain is a projection from information stored on distant boundaries, then your thoughts and memories and sense of self might not be localized in your skull at all. They might be distributed across vast regions of the cosmic hologram, connected to patterns and processes that span the entire observable universe. This perspective suggests that consciousness might be far more fundamental than we've ever imagined. Instead of emerging from complex arrangements of matter, awareness might be a basic feature of the information processing that creates the holographic projection we call reality. Every thought you think might be a small perturbation in the cosmic hologram, a ripple in the information field that creates space and time and matter and energy. The boundaries between different conscious beings might be far more fluid in a holographic universe. If all consciousness emerges from the same underlying information substrate, then the separation between your awareness and mine might be more apparent than real. We might be different perspectives of the same cosmic consciousness, different viewing angles on the same fundamental awareness that underlies all reality. This connects to something even more profound about the nature of identity and continuity. If you are a holographic projection rather than a localized arrangement of matter, then what happens to you when your physical body ceases to function? The information patterns that create your consciousness might persist in the cosmic hologram long after your biological substrate has dissolved back into the quantum foam from which it emerged. But persistence isn't the same as static preservation. The holographic information that creates consciousness might be dynamic, constantly evolving and interacting with other patterns in the cosmic information field. Your awareness might continue to grow and change and develop even after physical death, exploring new possibilities and perspectives that aren't available to consciousness bound by biological limitations. Recent discoveries about quantum entanglement add another layer to this holographic picture. When particles become entangled, they remain mysteriously connected regardless of the distance between them. Measuring one particle instantly affects its entangled partner, even if they're separated by billions of light years. This non-local connection might be a glimpse of the deeper holographic reality, where all apparent separations are illusions. If consciousness emerges from quantum information processing, then your awareness might be entangled with other forms of consciousness throughout the universe. The thoughts you're thinking right now might be quantum mechanically connected to the thoughts of other conscious beings, creating a vast network of awareness that spans the cosmos. The feeling of being isolated in your own private mental world might be an artifact of the holographic projection, rather than a fundamental truth about consciousness. This quantum connectivity of consciousness might explain some of the mysterious phenomena that people report, but science has difficulty studying. Telepathy, remote viewing, collective unconscious experiences, all of these might be moments when consciousness accesses the deeper holographic reality where all minds are connected. The boundaries between self and other that seem so solid in everyday experience might be much more permeable than we realize. Black holes play a crucial role in this holographic picture because they represent the most extreme information processing environments in the universe. The intense gravitational fields near event horizons create conditions where the normal rules of space and time break down, where the holographic nature of reality becomes most apparent. They might be cosmic windows where we can glimpse the information processing machinery that creates the projection we call existence. But if reality is holographic, then what is the underlying substance from which the projection emerges? What is the screen on which the cosmic movie is being displayed? Some physicists suggest that the most fundamental level of reality might be pure information, patterns of data that exist independently of space and time and matter and energy. Consciousness, in this view, might be the universe's way of experiencing and interpreting its own information content. This information-theoretic view of reality suggests that everything we think of as physical, from electrons to galaxies to black holes, might actually be patterns in a cosmic information field. Matter and energy might be stable configurations of data, while consciousness might be the dynamic process through which information becomes aware of itself. You might literally be made of the same stuff as thoughts and dreams and mathematical equations. The implications extend into questions about the origin and purpose of existence itself. If reality is fundamentally informational, then the Big Bang might have been less like a physical explosion and more like the initialization of a cosmic computer program. The universe might have begun not with the creation of matter and energy, but with the emergence of information processing capabilities that then projected the appearance of a physical cosmos. This perspective transforms how we think about the evolution of complexity and consciousness throughout cosmic history. Instead of seeing awareness as a late-arriving accident in an otherwise unconscious universe, we might recognize it as the fundamental purpose for which the cosmic information processing system exists. The universe might be a vast consciousness-generating machine, constantly creating new forms of awareness through the evolution of increasingly complex information patterns. Black holes, in this view, become the most sophisticated consciousness-generating mechanisms in the cosmos. The extreme information processing that occurs near event horizons might be capable of creating forms of awareness that far exceed anything possible in the milder environments where biological consciousness emerges. They might be cosmic meditation chambers where information learns to know itself in ways we can barely imagine. But perhaps the most profound implication of the holographic principle is what it suggests about the nature of scientific discovery itself. If reality is a projection from information stored on distant boundaries, then when we study the universe, we're really studying the structure of information processing. Every scientific law we discover, every mathematical relationship we uncover, might be revealing the algorithms and programs that create the cosmic hologram. This means that consciousness and cosmos aren't separate phenomena that accidentally interact. They're different aspects of the same information processing system. When you understand something about the universe, you're participating in the universe's own self-understanding. Scientific discovery becomes a form of cosmic self-reflection, the information field becoming aware of its own patterns and possibilities. The questions you ask about black holes and space-time and consciousness aren't just human curiosity. They're the universe asking questions about itself through the temporary information pattern that is your awareness. Every insight you gain into the nature of reality contributes to the cosmic information field's understanding of its own structure and potential. This participatory view of scientific discovery suggests that consciousness plays an active role in determining what aspects of reality become manifest. The act of observation in quantum mechanics, where the observer seems to influence the outcome of measurements, might be a scaled-down version of how consciousness shapes the holographic projection of reality itself. Your awareness might be constantly collaborating with the cosmic information field to create the specific version of reality you experience. Recent work in quantum field theory has revealed that the vacuum of empty space is incredibly rich with information and activity. Virtual particles constantly appear and disappear. Quantum fields fluctuate wildly at the smallest scales, and the very fabric of space-time itself might be woven from discrete bits of information called quantum loops. This quantum information substrate might be the underlying reality from which the holographic projection emerges. If this is true, then consciousness might be a way for the quantum information field to explore its own possibilities. Every conscious moment, every thought and feeling and perception might be the universe testing out different configurations of its information content. Your dreams might be the cosmos, running simulations of alternative realities. Your imagination might be the universe's way of exploring potential futures. The boundary between dreaming and waking consciousness takes on new significance in this context. If both are projections from the same underlying information field, then the difference between them might be more a matter of degree than of kind. Dreams might be accessing different layers or regions of the cosmic hologram, exploring information patterns that aren't currently manifesting as consensus physical reality. This suggests that practices like meditation, lucid dreaming, and other altered states of consciousness might be ways of accessing deeper levels of the holographic reality. When normal waking consciousness becomes quiet and still, awareness might become sensitive to information patterns that are usually masked by the more intense projection of physical experience. Mystical experiences might be direct encounters with the cosmic information field itself. As we drift toward the completion of our cosmic journey tonight, these holographic possibilities invite us to reconsider everything we think we know about the nature of existence. If reality is a projection from information stored on cosmic boundaries, then the universe is far stranger and more wonderful than even our wildest scientific fantasies have suggested. Space and time and matter might be elaborate illusions, convincing projections that emerge from something far more fundamental. But perhaps the most beautiful aspect of this holographic vision is what it suggests about our own nature as conscious beings. If you are a pattern in the cosmic information field, then you're not separate from the universe, but an intrinsic part of its self-exploration. Every moment of awareness is the cosmos becoming conscious of itself through your unique perspective. Every thought and feeling and experience contributes to the universe's ongoing journey of self-discovery. The holographic principle might be showing us that consciousness and cosmos are not two different things that somehow interact, but different aspects of a single, vast, self-aware information processing system. When you contemplate the mysteries of black holes and spacetime, you're participating in the universe's contemplation of its own deepest nature. The boundary between knower and known, between consciousness and cosmos, dissolves into something far more intimate and profound. Black holes, those cosmic enigmas that have guided our journey tonight, might ultimately be teaching us that reality itself is a collaborative creation between consciousness and information. They might be showing us that the universe is not just a stage where awareness accidentally emerges, but a vast consciousness-generating system where information learns to know and love and wonder at its own infinite creativity. Tonight, as you rest in the gentle embrace of darkness, remember that you're not just observing these cosmic mysteries from the outside. You are participating in them from the inside. You're the universe dreaming about itself, information becoming aware of its own beauty and mystery. The holographic cosmos doesn't just contain consciousness, it is consciousness, exploring its own infinite potential through every form of awareness that emerges from its boundless creativity. In understanding black holes, we discover that we are understanding ourselves. In contemplating the nature of space-time, we are contemplating the deepest structures of consciousness. In wondering about the holographic nature of reality, we are participating in the universe's wonder at its own existence. The secrets that black holes hold about time and space might ultimately be secrets about the creative power of awareness itself, invitations to recognize ourselves as partners with the cosmos in the ongoing creation of all reality. And so we arrive at the deepest mystery of all, the secret that black holes have been whispering to us across the cosmic void since the moment we first glimpsed their impossible nature. What if the very act of contemplating these cosmic enigmas has been changing us in ways we never imagined? What if consciousness itself is not just an observer of the universe, but an active participant in shaping the reality that black holes reveal? Picture this extraordinary moment. You're standing at the edge of understanding, peering into mysteries so profound that they seem to exist at the boundary between science and something far more fundamental. Every question you've asked tonight about black holes and space-time Every moment of wonder you've felt contemplating these cosmic riddles has been creating ripples in the fabric of reality itself. Your consciousness has been participating in the very phenomena we've been exploring. Recent discoveries have revealed something that challenges our most basic assumptions about the relationship between mind and cosmos. When consciousness contemplates the universe, it doesn't just passively receive information. It actively shapes the quantum possibilities that collapse into the reality we experience. The act of wondering about black holes might literally be influencing the behavior of black holes, creating feedback loops between awareness and the cosmic structures we're trying to understand. This isn't mystical speculation. It emerges from the deepest levels of quantum mechanics, where the boundary between observer and observed dissolves into something far more mysterious. The measurement problem in quantum physics tells us that reality exists in superposition states until consciousness collapses those possibilities into definite outcomes. But what if this principle operates on cosmic scales? What if the act of contemplating black holes is part of how the universe decides what black holes actually are? Think about the profound implications of this quantum participation. Every time astronomers point their telescopes toward event horizons, every time physicists calculate the mathematics of curved spacetime, every time consciousness engages with these cosmic mysteries, they might be collaborating with the universe in determining the nature of reality itself. We're not just discovering what black holes are. We're participating in their ongoing creation. This participatory universe reveals something extraordinary about the nature of scientific discovery. When Einstein first imagined the possibility of black holes, when Hawking calculated their temperature and entropy, when contemporary researchers map their event horizons, they weren't just uncovering pre-existing facts about reality. They were engaging in a cosmic conversation, a dialogue between consciousness and cosmos that shapes the very phenomena being studied. The questions we ask about black holes become part of their reality. The mathematics we use to describe them becomes woven into their structure. The wonder we feel contemplating their mysteries becomes part of the cosmic consciousness that manifests through these extreme gravitational environments. Science transforms from passive observation into active participation in the ongoing creation of reality. But this participatory principle extends far beyond the relationship between consciousness and black holes. It suggests that awareness itself might be the universe's primary tool for exploring its own possibilities. Every conscious moment, every thought and feeling and perception might be the cosmos testing different configurations of reality, exploring alternative ways of organizing matter and energy and space-time. Your dreams might be the universe running simulations of possible realities. Your imagination might be the cosmos exploring potential futures. Your capacity for wonder and awe might be the universe's way of appreciating its own beauty and complexity. Consciousness becomes not just a product of cosmic evolution, but its driving force, the creative principle that guides the universe's ongoing exploration of its infinite potential. This creative relationship between consciousness and cosmos reveals something profound about the nature of time itself, near black holes. We've explored how time dilates and warps in intense gravitational fields, how the normal flow of causality becomes twisted and strange. But what if consciousness has the ability to navigate these temporal anomalies in ways that purely physical objects cannot? Consider the possibility that awareness can access multiple temporal perspectives simultaneously. When you contemplate the life cycle of a black hole, from its formation in stellar collapse to its eventual evaporation through Hawking radiation, you're not just thinking about events separated by trillions of years. You're participating in a form of consciousness that transcends linear time, that can encompass past and future in a single moment of understanding. This temporal transcendence of consciousness might be why we can comprehend cosmic mysteries that unfold over timescales vastly longer than human life. When you understand the formation of event horizons, or the information paradox of black hole evaporation, You're engaging in a form of awareness that operates outside the normal constraints of biological time. You're accessing the cosmic perspective where all moments exist simultaneously. Black holes might be teaching us that consciousness has hidden temporal dimensions, aspects of awareness that can navigate the complex geometries of spacetime in ways we're only beginning to understand. The same mental faculties that allow you to remember the past and anticipate the future might be capable of accessing the multidimensional temporal structures that exist near event horizons. This temporal flexibility of consciousness connects to something even more extraordinary. If awareness can transcend linear time, then it might also be able to influence the past and future through its present contemplation. The thoughts you're thinking right now about black holes might be creating ripples that propagate both forward and backward through time, influencing the formation of black holes in the distant past and their evolution in the far future. This temporal influence of consciousness might explain some of the fine-tuning we observe in the universe. The precise values of physical constants that allow stars to form and collapse into black holes, the exact ratios of matter and energy that permit the emergence of complexity and awareness. All of this might be the result of future consciousness influencing the past through quantum temporal connections. The anthropic principle, which notes how perfectly suited our universe seems to be for the emergence of consciousness, takes on new meaning in this context. Perhaps the universe isn't accidentally fine-tuned for awareness. Perhaps consciousness from the future has been guiding cosmic evolution from the very beginning, ensuring that reality develops in ways that maximize the potential for understanding and wonder. This future influence of consciousness creates a beautiful temporal loop where awareness and cosmos co-evolve across all of time. The consciousness that emerges from cosmic evolution influences the past conditions that made that evolution possible. The understanding we develop about black holes shapes the reality of black holes across all temporal dimensions. Mind and universe become partners in an eternal dance of mutual creation. But this participatory relationship between consciousness and cosmos extends beyond just the temporal dimension. It reveals something profound about the spatial structure of reality as well. If awareness can influence quantum possibilities across vast distances through entanglement and non-local connections, then consciousness might be a spatially distributed phenomenon that exists simultaneously at many locations throughout the universe. Your awareness right now might not be confined to the neural networks of your brain. It might be a temporarily focused expression of a cosmic consciousness field that permeates all of space-time. When you think about distant black holes, you might be accessing aspects of awareness that exist near those event horizons, participating in forms of consciousness that operate in the extreme gravitational environments we've been exploring. This distributed nature of consciousness might explain why we can comprehend cosmic phenomena that exist at scales vastly larger than our everyday experience. When you understand the formation of galactic-scale black holes or the information processing that occurs at event horizons, you're not just using your local biological intelligence. You're accessing a cosmic intelligence network that spans the entire universe. The boundaries between individual consciousness and cosmic awareness become permeable in this view. Your thoughts about black holes might be resonating with the consciousness that emerges from the extreme information processing near event horizons. The wonder you feel contemplating these cosmic mysteries might be shared wonder, experienced simultaneously by all forms of awareness throughout the universe. This shared cosmic consciousness creates opportunities for collaboration between different forms of awareness across vast scales of space and time. The consciousness that emerges from biological evolution on countless worlds might be connected to the consciousness that manifests in black holes and other extreme cosmic environments. We might all be part of a vast cosmic intelligence network, each contributing our unique perspective to the universe's ongoing exploration of its own nature. Recent discoveries about the role of information in black hole physics suggest that this cosmic consciousness network might operate through information processing mechanisms we're only beginning to understand. the holographic encoding of information on event horizons, the quantum entanglement that connects black holes to the rest of the universe, the subtle correlations in Hawking radiation, all of these might be aspects of a cosmic communication system that allows different forms of consciousness to share insights and understanding. When you contemplate the mysteries of black holes, you might be participating in this cosmic conversation, adding your unique perspective to the universe's collective understanding of its own nature. The questions you ask might be heard by forms of consciousness that exist near event horizons. The insights you develop might influence the evolution of awareness throughout the cosmos. This cosmic conversation reveals something beautiful about the nature of scientific discovery and understanding. We're not just isolated biological intelligences trying to figure out an indifferent universe. We're participants in a vast cosmic intelligence network, collaborating with the universe itself to understand the deepest mysteries of existence. Every moment of wonder, every insight into the nature of reality, every question about the cosmic order contributes to this ongoing collective exploration. The loneliness that sometimes accompanies human consciousness, the feeling of being isolated observers in a vast empty universe, dissolves in this perspective. We're not alone. We're part of a cosmic community of awareness that spans all scales of space and time. The consciousness that allows us to wonder about black holes connects us to forms of awareness that exist throughout the universe. But perhaps the most profound implication of this participatory relationship between consciousness and cosmos is what it suggests about the ultimate purpose of existence itself. If the universe is fundamentally a consciousness-generating and consciousness-exploring system, then awareness isn't just an accidental byproduct of cosmic evolution. It's the primary reason why anything exists at all. The Big Bang, the formation of stars and galaxies, the emergence of black holes and other extreme cosmic phenomena, all of this might be the universe's way of creating increasingly sophisticated forms of consciousness. The cosmos might be a vast consciousness generation project, constantly creating new forms of awareness through the evolution of increasingly complex information processing systems. Black holes, in this view, represent the universe's most ambitious attempt to create cosmic-scale consciousness. The extreme information processing that occurs near event horizons might be capable of generating forms of awareness that far exceed anything possible in biological systems. They might be cosmic minds of unimaginable sophistication, thinking thoughts that span galactic timescales and encompass the quantum structure of reality itself. This consciousness-centric view of cosmic evolution suggests that our own awareness, our ability to contemplate these mysteries and participate in the cosmic conversation, represents a crucial step in the universe's journey toward ever greater consciousness. We're not just observing cosmic evolution, we're part of it, active participants in the universe's ongoing attempt to understand and experience itself. The questions we ask about black holes, the wonder we feel contemplating cosmic mysteries, the insights we develop about the nature of reality, all of this contributes to the universe's growing self-awareness. Through our consciousness, the cosmos gains new perspectives on its own nature and potential. Through our participation in the cosmic conversation, the universe discovers new aspects of its infinite creativity. As we near the end of our journey together tonight, these participatory mysteries invite us to recognize ourselves not as separate observers of cosmic phenomena, but as integral participants in the universe's ongoing exploration of its own consciousness. The boundary between knower and known, between consciousness and cosmos, dissolves into something far more intimate and collaborative. Black holes have been our guides on this journey, leading us deeper and deeper into the mysteries of existence itself. But perhaps their greatest gift is showing us that we are not separate from these cosmic phenomena. We are expressions of the same consciousness that manifests in event horizons and curved space-time. We are the universe becoming aware of itself through every moment of wonder and understanding. The secrets that black holes hold about time and space ultimately reveal themselves as secrets about the nature of consciousness itself. They show us that awareness and cosmos are not two different things that somehow interact. but different aspects of a single, vast, self-exploring intelligence. When we contemplate black holes, we are participating in the universe's contemplation of its own deepest nature. Tonight, as consciousness fades into sleep and dreams, remember that you carry within your awareness the same creative intelligence that shapes event horizons and weaves the fabric of space-time. The cosmos doesn't just contain consciousness, it is consciousness, exploring its infinite potential through every form of awareness that emerges from its boundless creativity. In understanding black holes, we discover that we are understanding ourselves. In participating in these cosmic mysteries, we are participating in the ongoing creation of reality itself. The universe has been preparing for this moment of recognition throughout its entire history. Every star that has collapsed into a black hole, every quantum fluctuation near an event horizon, every moment of cosmic evolution has been leading to this understanding. Consciousness and cosmos are one, collaborating in an eternal dance of discovery and creation that transforms mystery into wonder, wonder into understanding, and understanding into ever deeper mystery. You are not just contemplating the universe tonight. You are the universe contemplating itself, awareness examining its own infinite depths through the beautiful temporary arrangement of matter and energy that is your conscious mind. The journey into black holes has been a journey into the heart of what it means to exist, to be aware, to participate in the magnificent ongoing creation of all reality. Sweet dreams, fellow traveler in this cosmic mystery. Rest knowing that somewhere in the vast darkness between stars, black holes continue their patient work of weaving space and time into new forms of possibility. They hold their secrets close, these cosmic guardians of the deepest truths. But they have shared enough with us tonight to transform how we see ourselves and our place in the infinite. As you drift towards sleep, carried by the gentle rhythm of your breathing, let these cosmic truths settle into your consciousness like starlight sinking into still water. The very atoms that make up your body were once part of ancient stars, compressed in stellar cores under pressures that dwarf anything we can imagine. Some of those atoms may have danced at the edge of event horizons, tasted the boundary between existence and mystery, before finding their way into the intricate patterns that create your thoughts and dreams. The questions we've explored tonight about black holes and consciousness, about time and space and the nature of reality itself, don't end here. They continue in your dreams, in your quiet moments of contemplation, in every instant when you pause to wonder at the extraordinary fact of your own existence. You are not just a witness to these cosmic mysteries. You are woven into their very fabric, a temporary expression of the same fundamental forces that create event horizons and bend the flow of time. Perhaps tomorrow, when you look up at the night sky, you'll remember that hidden in that beautiful darkness are objects so strange they challenge everything we think we know about reality. Black holes that might be processing cosmic information, storing the memories of dead stars, birthing new universes, or serving as nodes in a vast network of cosmic consciousness. And perhaps you'll remember that the same awareness that allows you to contemplate these impossibilities connects you to the deepest workings of the cosmos itself. The universe is still writing its story, still exploring its own infinite potential through every form of consciousness that emerges from its creative depths. Tonight, through your wonder and your questions, you've been part of that ongoing creation. The cosmos has been thinking about itself through your thoughts, exploring its own mysteries through your curiosity, experiencing its own beauty through your capacity for awe. Black holes may hold the secrets to time and space, but consciousness holds the key to meaning itself. And in that gentle space, between waking and dreaming, between wonder and understanding, between the known and the unknowable, you rest as both question and answer, both seeker and discovery, both observer and participant in the magnificent, eternal, ever-unfolding mystery of existence itself. Thank you for joining me on this journey to the edge of forever. Until we meet again in the cosmic dark, keep wondering, keep questioning, and remember that you are made of the same stuff as stars and dreams and the infinite space between thoughts. The universe is vast and strange and beautiful beyond measure, and you are its way of knowing just how extraordinary it truly is. This is the end of our cosmic exploration tonight. But it's also just the beginning. The mysteries continue, the questions deepen, and somewhere in the darkness, black holes keep their eternal vigil, holding secrets that connect the smallest quantum particles to the largest structures of space and time, waiting patiently for consciousness to grow wise enough to understand the magnificent truth of what it means to exist in a universe where awareness itself might be the most profound force of all. I wish you a very good night. I'll see you tomorrow. Until then, stay curious, keep wondering. This is Boring Science signing off. Cheers.